All right, let's talk about partial pressures and gas collections. So gas collection, anytime we want to collect a pure sample of a gas, it's trickier than collecting a solid. A solid we can filter out, liquid we can collect inside of a container, but gases, if we just let two things react that produce gas, so for example, we've got hydrogen peroxide and sodium chlorate right here. When we react those, we get sodium chloride and water. If we wanted to collect this oxygen, if we were just to mix them in an open flask, poof, the oxygen would go everywhere. So in order to collect pure samples of gases, we collect them over water. And so right here we just have a trough filled with water and then a graduated cylinder or a eudemitor, some other method for collecting gases, also filled with water. So the trick with filling it with water then, that means there is no gas in here. If we were just to tip this upside down when it was full of air, that means it's already got oxygen in it or it's already got other gases in it. So when we try and collect O2, it's going to mix in there and we get a really impure sample. But this way we can collect just pure oxygen. And so as the bubbles are formed, they bubble up inside here, and then the bubbles would displace the water, and so we could collect a certain amount of oxygen, or we could calculate out how much we collect. We could also figure out the pressure of the gas inside of that test tube that we're collecting it in, test tube, graduated cylinder, whatever it is, by comparing it with the atmospheric pressure on the outside. So we talked about barometers and how atmospheric pressure can push down the liquid and cause the water level to rise. So what we would do then is we would line it up so that the water level inside of our graduated cylinder is the same as the water level outside. What that tells us then is the pressure of the air on the outside is equal to the pressure inside. And atmospheric pressure inside of a room is really easy to find. There's barometers and weather instruments that will measure atmospheric pressure. So if we know the atmospheric pressure, the water level is lined up, we know the total pressure inside of that container. However, one of the tricks with collecting gases over water is water creates a vapor pressure. We talked about vapor pressures a little bit last unit. So vapor pressure is the pressure caused by some of these liquid molecules, the H2Os, actually entering the gaseous phase. And so they're evaporating right here. And so as a result, we're going to have some water vapor inside of this container as well. And so then the total pressure that's inside of the cylinder is not going to be just the oxygen or whatever the gas is that we collected. It would be the pressure of oxygen plus the pressure of water. The good news is if we know the temperature of this water, we can figure out the pressure of the oxygen very, very easily. The pressure of the water very easily. So there's tables that would show us then, and if we know what the pressure of the water is, the pressure total minus the pressure of the water would give us the pressure of just the oxygen. If we got the pressure of oxygen, we can use it in Pervnert, figure out the number of moles, do all kinds of fun stuff with it.